All right, let's jump straight into this explainer. Today, we are officially leaving reactive panic in the dust and moving toward proactive, data driven performance resolution. We're going to unpack Sentry performance monitoring and exactly how it gives you the power to find those sneaky, slow transactions way before they ever start impacting your users.
Because, well, we've all been there, right? It starts with the universal developer nightmare, a frustrated user complaining about performance, but giving you absolutely zero context. They just say, the checkout page is so slow. Okay, great, but what does slow actually mean here? Was it their spotty Wi Fi? Was it a massive unoptimized image on the front end? Or is the database locking up on the back end?
And that brings us to the core mystery of our investigation today. How on earth do we measure the user's pain when we are essentially flying blind? Without the right telemetry, you're just stuck combing through disjointed server logs or trying to replicate the issue on your own machine, which, let's be honest, always runs perfectly fine. We need a way to see exactly what that user experienced.
The answer? Distributed tracing. This is Sentry's way of capturing the complete journey of a request across your entire architecture. So instead of just tracking an error in isolation, distributed tracing assigns a globally unique trace ID to a user's action, like, say, clicking a checkout button, and it follows that exact request as it travels from their browser, straight through your API, and deep down into your database. Think of it kind of like a Russian nesting doll of telemetry. At the very top, you have a trace, which is the global request journey. Crack that open, and inside you'll find transactions. These are top-level events, like a page load or an API call. Crack those open, and transactions are made up of spans. A span is simply the smallest unit of work. It's a granular, timed operation like a single SQL query or a file read. And here's where it gets really cool. Sentry actually maps those human-centric web vitals on the front end directly to the back-end metrics causing the delay. Sentry isn't just looking at server health. It tracks core web vitals like largest contentful paint. So if a user gets a slow page load, you instantly know if it was a front-end rendering issue or if a slow database query was holding everything hostage. It perfectly bridges the gap between what the user perceives and what your infrastructure is actually executing.
Reading the transaction waterfall, let's see how to actually spot the bottleneck.
When you look at the chronological flow of a waterfall view, it shows you exactly where time is being spent during a transaction. The spans execute sequentially. You've got the initial page load right at 0 milliseconds, followed by the authentication API call, and then your sequential database queries. Since child spans fall directly under their parents, it is incredibly easy to identify which specific operation is holding up the whole request. And honestly, you don't even have to hunt for these issues because Sentry literally highlights the anomalies for you. If you drill down into a child span and there's a massive latency spike hitting that 500 millisecond threshold, Sentry flags it. If a select query consistently takes that long and happens frequently, the system detects it automatically and tags it as a slow DB query. That long bar in the waterfall just glows right in front of you. No guessing required.
You know what else this view almost always exposes? The dreaded N+1 query pattern. This is that classic silent performance killer, where your app executes one query to fetch parent objects and then fires off a separate query for every single child object. It crushes performance as you scale. But Sentry's automated detection spots these repetitive sequences instantly. In fact, one real-world example from our source material showed that fixing an N+1 query found this way led to a 94% reduction in query time. That is absolutely massive. So finding the issue is great, but we really want to prevent the fallout. Nobody wants to discover a major performance degradation through an angry Twitter thread, right? By setting up smart alerting, Sentry automatically pings your engineering team's Slack channel the precise moment performance dips below your accepted baseline. Setting a P95 latency threshold is absolutely crucial here because it ensures you're capturing the experience of your slowest users. You're getting pinged before support tickets even get drafted, and you have some really powerful options. You can use static thresholds, like alerting if P95 exceeds 800 milliseconds. You can set a percent change alert, which fires if latency suddenly jumps 20% from the previous hour, or you can use anomaly detection, where Sentry dynamically figures out if values are falling outside of historical norms. Let's put this into a real-world scenario. Imagine an e-commerce checkout page that is suffering from a horrific P95 latency of 8 seconds. Yeah, 8 seconds. In the e-commerce world, that is practically an eternity. That doesn't just mean a frustrated user. That literally translates to abandoned carts and direct measurable revenue loss.
So what does your proactive workflow actually look like now? Bam, your Slack channel gets the automated P95 metric alert. A developer clicks straight from Slack into Sentry's trace view. They expand the waterfall and instantly spot a huge sequence of N+1 database queries choking the payment processing API. And because Sentry links this right to the exact code repository, they escalate the precise issue to the dev team immediately. Your time to resolution just dropped from hours to minutes.
It is literally night and day compared to the dark ages of reactive monitoring. Back then, you'd be downloading gigabytes of logs, squinting at server timestamps, and basically just guessing what happened. Now, in this proactive state, Sentry just hands you the exact line of code that needs fixing right alongside the actual SQL query text that was executed.
But honestly, this right here is the holy grail of observability: correlation. Sentry actually connects that 8-second slow transaction directly to a corresponding error. So if a long-running database query eventually causes an API timeout error, you get to see both the slow performance span and the resulting crash on the exact same trace timeline. It gives you the complete diagnostic narrative in one unified view.
So the big takeaway from this explainer is simple. Performance is a feature, and hope is definitely not a monitoring strategy. If you want to poke around and see this for yourself, you can actually explore these trace views in the Sentry demo project. Just head over to sentry.io and grab a free account. But the real shift here is your mindset. When your next major latency spike hits, will you be the detective who already solved the case, or the victim waiting for the complaints to roll in?